Welcome back to another homework solution video. This is for Chapter 6, Lesson 1, Day 1. We are beginning our work with percentages. So if you're feeling like you need extra practice, check out textbook page 313, numbers 1 through 4. So I'm going to be definitely thinking about what would be reasonable given this scenario. So remember, percentages are comparing quantities to 100. So if 100 is our base, if that's our whole, how much of that 100 is going to be taken up, or like how much does that quantity represent? So of the 300 plants in a park, 180 are trees and the rest are flowering bushes. What percent of the plants in the park are trees? So this question could have gone two directions. It could have asked us about the trees, or it could have asked us about the bushes. And I see here our numbers that 180 out of 300 are trees. Now, if I'm thinking about this as a percent, it's going to be a number between, well, we can't have more than the number of plants be trees, so it's going to be between 0 and 100%. And I know half of 300 is 150. So I know that there are more than half of the plants are going to be trees. So if I get a percent that's less than 50%, that means that less than half of the plants are trees, then I know I've probably done something wrong. So our easiest way to think of these is to use fractions with a denominator of 100, because that means that our whole contains 100, and so we're comparing our quantity to 100, which is the definition of percent. So 300 divided by 3 equals 100. So I'm going to do the same thing to my numerator because I am a master of equivalent fractions. 180 divided by 3 is 60. So this means 60% of the plants are trees. So that is a little bit more than half, because 50% is half, and it looks like there are a little bit more than half of the plants being trees. So this seems to check out. Question number 2. 13 out of 20 students. Ooh, that's more than half. Okay, wear glasses. What percent of the students do not wear glasses? So, tricky. Which ones do not? So if 13 out of 20 wear the glasses, that must mean that 7 out of 20 do not. And that is the piece of information that we need. So this helped me, but only so far. So we need to convert 7/20ths into a fraction with 100 as the denominator, because that will allow us to compare per for each cent 100. So 20 times 5 is 100. So I need to do 7 times 5. And I would get 35 out of 100, or 35%. So 35% of students do not wear glasses. Okay, great. 16 of 40 students said that blue is their favorite color. So I'm going to switch to blue pen in their honor. What percent of students love blue the most? So as a fraction, I know 16 out of 40 love blue the most. And I know half of 40 is 20%, or is 20. So I know that if I get a percent that is going to be greater than 50%, I've made a calculation mistake somewhere in here. So in our previous problems, we've looked at how can we make this fraction. Well, how can we find an equivalent fraction with 100 as the denominator? And I know that if I skip count by 40s, 40, 80, 120, I can't multiply this and get right to 100. But I do notice that if I'm skip counting and I get to 80, 80 only needs to be added 20 more on there, and 20 is half of 40. So I'm going to just double check, and I know that 40 times 2.5 is the same as 40 times 2, and 40 times a half. 40 times 2 is 80, 40 times a half is 20, so that is 100. So I could multiply these by 2.5. And so 16 times 2.5 is a 16 times 2, which is 32. And a 16 times a half of 16 is 8. So that is 40. So 40 out of 100. Now, I don't know about you, that's a less, it's doable with these numbers because they work well like that, but I'm going to see if there's another way that I can solve this to check myself. So I know, thinking about my factors of 40, I know 1 and 40, not super helpful, 2 and 20. Ooh, that could be good because I'm trying to find some overlaps between factors of 40 and factors of 100. And I know that 100 has some of these. And so I could use this factor of 20 to help me out because I know 16/40ths is the same as 8/20ths. And then I know 8/20ths is equivalent to, I multiply that by 5, 40/100ths. So it does add an extra step in there, but it got us the answer that we needed. So you can always look and see, like, is there a way that I can get from where I'm starting at to where I need to be with like a stopover in between. So what percent of the students love blue the most? We have two options here. 40%, either way we got it, love blue the most. 40% love blue. Okay, question number 4. Mr. Plaska took a trip to Phoenix. He drove 84 of the 350 miles above the speed limit. Bro, danger, speeding. I'm not condoning breaking the law or reckless driving. It's just I needed some numbers to work for this problem. So we want to know what percent of the trip did he drive at or below the speed limit. So that means this is how much he was above it. We need to find out at or below, so the other portion of this. So we have a couple options. We could do like we did up here, where we took this number and of the ones that do wear glasses, but the question was asking about do not. So we found that fraction that do not right away and then converted that. Oh, I'm going to sneeze. 1 second. Woo, excuse me. So we could do that, but I feel like this number 84 is going to get really large and that might be more difficult to work with. So I think I'm going to stick with this 84 first. So as a fraction, 84 out of 350. Now, we need to get 350 to a 100. So we could do some division. Looks like maybe if we divided by 35, because I know 350 divided by 35 would equal 100, but 84 divided by 35 is not super friendly in this case at all. So I'm going to see if there's another route that I can get there. And so I'm going to do some thinking like I did up above, up here, where like what are some factors that might be in common, or what are some equivalent fractions for 84 350ths that would be a nice stopover to get me to a 100. So looking at my list of factors for 100, we know 1 and 100, 2 and 50, 3, nope, no threes, 4 and 25, 5 and 20. So I'm just going to stop there because that gives me plenty of options. And I recognize right away that 350 is like a 35 and that 5. So I feel like 50 could be a nice stopover in between there. I could also do 25, but I think I'm going to divide here instead to get a fraction with a 50 in the denominator, because once I arrive there, it becomes very nice for me to get from 50 to 100. So 350 divided by something is going to equal 50. So I know 350 divided by 7, because 35 divided by 7 is 5. So 350 divided by 7 is 50. And that works out nicely with 84 can also be divided by 7, and that is 12. Okay, so now that we have 12 50ths, might as well multiply by 2 to get 24 100ths. So it seems like I drove 24% above the speed limit. So 24% of the trip was above. But the question is asking how much was it below. And so I'm going to have to do 100% minus 24, and that is going to be 76%. So I drove 76% of the trip at or or below the speed limit. And if we check, that is correct there. So this is just our intro, our warm-up, and as you can tell, it's just a different application of concepts that you already know. Good luck.